All right, so picture this. You're leading um, a team of brilliant minds, right? You've poured years of work and over $100 million into building a spacecraft, and then it all goes up in smoke, poof, gone, because someone mixed up inches and centimeters.
Oh, wow.
You'd think that only happens in movies, right?
Yeah, you would think that.
But this was the very real story of the Mars Climate Orbiter.
It sounds unbelievable, but
Oh.
it really highlights how crucial those seemingly small units are.
Yeah.
Especially in complex projects like space exploration.
Yeah, the 1999 Mars Climate Orbiter mission was a huge deal for NASA. It was meant to study the Martian climate and the atmosphere, look for changes on the surface.
Right.
It was even going to act as a communications relay for future missions. Talk about ambitious.
Absolutely. And the failure was a major setback, not just financially, but for the scientific community as a whole.
So what exactly went wrong? I mean, it can't be as simple as someone just reading the wrong number, right?
You're right, it's more nuanced than that.
Yeah.
The problem was a mismatch in the units of force used by the different teams working on the project. So Lockheed Martin, who built the orbiter, used the English system, inches, feet, pounds.
Okay.
While JPL, the Jet Propulsion Laboratory handling navigation, worked with metric units, millimeters, meters, and newtons. They're a NASA center responsible for robotic space missions.
Got it. Thanks. Okay, so two different systems running at the same time. How did that slip through the cracks? Didn't we try to get the world on the same page with measurements? Like, isn't the metric system supposed to be the universal language of science?
Well, in theory, yes. The metric system, which originated during the French Revolution, was designed to simplify things. Logical base units like the meter for length and the gram for mass, with prefixes for larger or smaller units. It's a beautifully elegant system.
But here in the US, we seem to be clinging to our inches and pounds for dear life.
You're not wrong. The US is one of the few countries that still heavily relies on the English system, despite a push towards metric with the Metric Conversion Act of 1975. However, the lack of strong enforcement meant that many industries, including parts of NASA, continued to use the older system.
So we had these two measurement languages running in parallel, and in the case of the Mars Climate Orbiter, they collided. Literally.
Yeah.
It's kind of mind-boggling that something like this could happen, especially with all the brilliant minds working at NASA.
You would think, wouldn't you?
Yeah.
But this situation reveals how deeply ingrained cultural preferences for certain measurement systems can be, even within a scientific organization like NASA.
It's almost like there was a blind spot, a subconscious bias towards the familiar, even when it wasn't the best choice for the project.
Precisely. The Mars Climate Orbiter disaster became a stark lesson in the importance of standardized units and the need to overcome such biases, particularly in large-scale projects where seamless communication between teams is critical.
So it wasn't just one person messing up a conversion, it was a systemic issue with roots in historical practices and cultural preferences.
Exactly. And it brings up a bigger question. Is the Mars Climate Orbiter case a one-off? Or are there other instances of unit mix-ups causing chaos out there? And remember, stay curious, stay vigilant, and always stay unit aware. You never know when that knowledge might come in handy.
That's all the time we have for today's deep dive. Thanks for joining us, and until next time, keep those units in mind.